then real part of one should be equal to real part of other except root under negative. Inside root, if you have negative, it is not real. So a number of the form z is equal to a plus ib, where a comma b belongs to real numbers. Complex number means a number of the form z is equal to a plus ib. So number of the form z is equal to what? A plus ib. Add real part plus I times add imaginary part plus imaginary. Z1 plus group Z2 and Z3. Z1 plus Z2 and Z3 is same as Z1 plus Z2 plus Z3. Welcome to the session, dear students. In today's session, I am going to start with an important chapter, that is complex numbers and quadratic equations. So you have already studied quadratic equations in your lower classes, that is in your 10th standard or 9th. But now we will study complex numbers. Apart from real numbers, we have a special number system, that is complex numbers. So now, what is a complex numbers and what are quadratic equations? Quadratic equations, you know, degree 2 equations. So first we will start with what is a complex number. So now, to start with this complex number, first let me brief out what is the weightage for this chapter. For a board exam, complex numbers and quadratic equations, that is chapter 5, for first PUC board exam, total 9 marks. One 1 mark question in part A and one 2 mark question in part B and 2 3 mark questions. So 2 3s are 6 marks in part C. In part A, B, C, questions will be there. One question in part A, that is for 1 mark. One question in part B, that is for 2 marks. And 2 questions in part C for 3 marks. Total 6 marks. So 6 plus 2 plus 1, 9 marks. This is a weightage. So I can say good weightage for this chapter. One 1 mark question, one 2 mark question, 2 3 mark questions will be asked in PU board exams. So according to the blueprint, or if you refer the past board papers, this is the weightage they have maintained from this chapter. What is the name of the chapter? Complex numbers and quadratic equations, chapter 5. What is the weightage? Total 9 marks. One 1 marker, one 2 marker and 2 3 marker questions will be asked in your board exams. Now, first we will see what is the definition of complex number. Any number we cannot call it as complex number. Complex number means a number of the form z is equal to a plus ib. So number of the form z is equal to what? A plus ib. A number which is in the form z is equal to a plus ib. For example, z is equal to 4 plus 5i. So now it is in the form a plus ib, where a is real part and b is imaginary part and I is root of minus 1. What is I? Root of minus 1. In this a plus ib, a comma b belongs to real numbers. A and b belongs to real numbers. What are real numbers? All numbers, natural numbers, whole numbers, integers, fractions, irrational, all are real numbers except root under negative. Inside root, if you have negative, it is not real. So a number of the form z is equal to a plus ib, where a comma b belongs to real numbers and I is equal to root of minus 1. And what is I? Root of minus 1. And root of minus 1 is called as imaginary number. That's why a is real part, b is associated with I. That's why b is called as imaginary part. What is a complex number? A number of the form z is equal to a plus ib. A number of the form z is equal to a plus ib is called as complex number, where a and b are real numbers and a is called as real part, b is called as imaginary part and I value, remember I value, what is I? Root of minus 1. Example I write 4 plus 5i. Here 4 and 5 are real numbers, I is root minus 1. And one more example, minus 3 plus 2i. This is also, because minus 3 comma 2 belongs to what? Real numbers. And another complex number, say 4 minus 9i. This is also complex number. Why? Because here it is in the form of, can I write 4 plus minus 9 into I? So now 4 comma minus 9 are in the form of a comma b. So these two are real numbers. So these are all the complex numbers. So my dear students, what is a complex number? Number of the form z is equal to a plus ib, where a and b are any real numbers, I is root of minus 1. So inside the root, if you have negative, we call it as what? Imaginary. Now, so all of you know what is root 4? Root 4 is 2. Why? Because 2 into 2. Do you agree? Similarly, what is root 9? Root 9 is 3, because 3 3s are 9. Do you agree? But if I give you root minus 4, I cannot say it is minus 2. It is not minus 2. Why? Because minus 2 into minus 2 becomes what? Plus 4. So I cannot see square root means so two similar numbers. That's why under the root if you get negative we say imaginary. So that's why we'll write this as what? Root minus 4 can be written as, I'll write it as 4 into minus 1 under root. Further I can write root 4 into root minus 1. Root 4 is 2i. Means always we symbolize root minus 1 as what? I, imaginary number, iota or imaginary number. So now let me conclude some important concepts. First, what is the definition of complex number? Any number of the form z is equal to a plus ib, where a comma b are real numbers and I is root minus 1, we call it as complex number. And the term without I, this is real part, the term is associated with I, we call it as imaginary part. So ಇಲ್ಲಿ ಐ ಜೊತೆಯಲ್ಲಿ ಇರೋದನ್ನ ಇಮ್ಯಾಜಿನರಿ ಅಂತ ಹೇಳ್ತೀವಿ, ಅದರ ಟರ್ಮ್ ಬೇರೆ ಟರ್ಮ್ನ ರಿಯಲ್ ಪಾರ್ಟ್ ಅಂತೀವಿ. ರಿಯಲ್ ಪಾರ್ಟ್ ಇಸ್ ಎ ಆ್ಯಂಡ್ ದಿಸ್ ಇಸ್ ಇಮ್ಯಾಜಿನರಿ ಪಾರ್ಟ್. ಸೊ ಐ ರೋಟ್ ಎಕ್ಸಾಂಪಲ್ 4 plus 2i, 2 minus 5i, 1 plus 6i. These are all the examples of complex number. And remember, any number can be written in terms of complex number. For example, I'll give 5. You can write 5 as, can I write 5 is equal to 5 plus I into 0? Do you agree or not? What is I into 0? 0. 0 into anything. So this is in the form a plus ib. Here what is a? A is 5 and what is b? B is 0. So you know these two are real numbers. I is root of minus 1 or of and see here only we had 5. 5 means only we have a term without I. So if you have only a, z contains only a, then we say purely real. Purely real. Purely real means b is 0. Purely imaginary means a is 0, like that. Further we'll see. So now I want you people to become thorough with that definition. What is complex number? A number z is equal to a plus ib is called as complex number, where a comma b is real part and I is root of minus 1. Now two complex numbers. Let us consider comparison of two complex numbers. That we say equality of two complex numbers. When can you say two complex numbers are equal? Always two complex numbers are not equal. If two complex numbers are equal, then real part of one should be equal to real part of other and imaginary part of one should be equal to imaginary part of other. Remember this. So that's why we say two complex numbers z is equal to x plus iy and z2 a plus ib. We say they are equal if and only if the real parts are equal. The first element, that is x, should be equal to a, and here y, quotient of y, I should be same, y should be equal to b. For example, if I take a plus ib is equal to 3 plus 2i, I am equating two complex numbers. Two complex numbers are said to be equal if the real part of first is equal to real part of second and imaginary part of first should be equal to imaginary of second. So now they gave a plus ib is equal to 3 plus 2i. They gave two complex numbers are equal. If two complex numbers are equal, then the real part should be equal and imaginary part should be equal. What is real part here? A should be equal to real part here. What is the real part here? 3. And what is the imaginary part? Quotient of I. What is quotient of I here? B. Here what is the quotient of I? 2i. So 2. So that's what I wrote. A is 3, B is 2. If two complex numbers are equal, then their real part should be equal separately and imaginary part should be equal, and vice versa. If real part of one complex number is equal to real part of other and imaginary part of one is equal to imaginary part of other, then they are equal. Now my question to you, if I tell x plus 2i is equal to a plus is equal to, I'll write 5 plus x plus 2i is equal to 5 plus bi. I wrote two complex numbers. I am telling they are equal. The first one equal to second one. Then that implies the real part of first should be equal to real. What is the real part here? X. Here what is the real part? 5. So x is 5. And imaginary of first should be equal to imaginary of second. What is imaginary of this? 2. What is imaginary of this? B. So b should be equal to 2. So x is 5 and b is 2. So I hope all of you understood what is equality of complex numbers. Two complex numbers are said to be equal if real part of first is equal to real part of second and imaginary part of first equal to imaginary part of second. Real part means the term without I. Imaginary part means the term with I. Now answer my question. If I give 6 plus 9i, what is real part? Real part is real part of z. R of z is 6. What is imaginary part? Imaginary part of z is 9. The term with I is called as imaginary. The term without I is called as real. And when can you say two complex numbers are equal? two complex numbers are said to be equal if real part is equal to real part and imaginary part of first number is equal to imaginary part of second number. That's what I've given an example also. Now we'll go to the addition of two complex numbers. How to add two complex numbers? Simple. Add the real part plus add the imaginary parts. Normal algebraic addition you can do. That's what I can say. Or I can say real part plus I times imaginary part plus imaginary part. So now if I take complex number z1 is equal to a plus ib and z2 is equal to x plus iy, and if I want to perform z1 plus z2, then real part plus real part. Real part is a and here it is x, a plus x plus b plus y, I. That's it. Or I into b plus y. Simply speaking, like terms you add. Suppose example, if z1 is equal to 3 plus 2i and z2 is equal to 4 plus 5i. Two simple complex numbers I have taken. If you ask me to perform z1 plus z2, addition and subtraction both will see. z1 plus z2, real part plus real part, 3 and 4, 3 plus 4, plus imaginary part plus imaginary part, 2i plus 5i. Or you can take I common, 3 plus 4 is 7 and 2i plus 5i is 7i. So 7 plus 7i, that's it. This is a complex number. When you add two complex number, final answer is also a complex number. And adding real plus I times imaginary plus imaginary, or add like terms and take common. 2i plus 5i is 7i, like normal algebra. Or take I common and add these two. 2 plus 5 is 7, 7 times I, that's it. Addition of complex number is simple like any algebraic addition. Subtraction is also same. Real minus real plus I times imaginary minus imaginary. Same thing will perform. If I ask you people to find z1 minus z2, what is z1 minus z2? 3 plus 2i minus 4 plus 5i. So expand this, 3 plus 2i, open the bracket, so it will become minus 4 minus 5i, and 3 minus 4, 3 minus 4 is minus 1, and 2i minus 5i, 2i minus 5i becomes minus 3i. This is the answer. Or I can also write this as what? Minus 1 plus minus 3 times I. And the other version is what? Subtract real part. So z1 minus z2 is subtract real parts. What is the real parts? 3 and 4. So 3 minus 4 plus I times subtract imaginary 2 minus 5i. So if you do, you will get minus 1 minus 3i, or minus 1 plus of minus 3i. You can write one another same. Addition and subtraction perform like normal algebraic addition and subtraction. That's all. So now if I ask you to find if z is equal to 3 minus 2i, z1, and z2 is equal to 4i. What is z1 minus z2? z1 plus z2? Normal addition, 3 minus 2i plus 4i. That is 3 minus 2i plus 4i is 2i, 3 plus 2i. Then if I ask you to find z1 minus z2, what is z1 minus z2? Subtract. So 3 minus 2i minus 4i. What is 3 minus 2i minus 4i is minus 6i. So subtraction and addition of two complex numbers. Then we'll talk about properties. The first property is closure law. What is meant by closure law? Addition of two complex numbers is a complex number. So if I take z1 belongs to complex number and z2 belongs to complex number, after you add, you will get a complex number. That we say closure. Closure means what? Sum of two complex numbers is a complex number. Closure property says sum of two complex numbers is complex number. For example, sum of two complex numbers is a complex number. Means if I take z1, take any complex number. So now we are discussing closure law. What is closure law? So if I take two elements belonging to complex numbers, then their sum is complex number. Sum of two complex numbers is also complex number. Then we say addition is closure. So z1, take any complex number. I will take 2 plus 5i. And I will take another complex number, say z2. What is z2? So z2 I will take 4 plus 3i. So now you can see z1 belongs to C as well as z2 belongs to C. Means I have taken two complex numbers. So conclusion is simple. So z1 and z2 belongs to C. So now perform the addition. So do z1 plus z2. If you do addition of two complex numbers I told you, you can add in two methods, real plus I times imaginary plus imaginary. So what we do, 2 plus 4 plus I times 5 plus 3. So if you do that, so it will become 6 plus 8i. So now it is in the form a plus ib. So therefore this also belongs to what? Complex number. So therefore what is the conclusion? Sum of two complex numbers is a complex number. Therefore it obeys closure law. So now I explain what is closure law. What is closure law? Take two complex numbers and you add them. Your final answer is also a complex number. Now second one, commutative law. Commutative means z1 plus z2 is same as z2 plus z1. However you add, both are same. You do z1 plus z2 or you do z2 plus z1, final answer will be same. That we say commutative law. So addition is also commutative. Addition is also commutative. So now I need to prove commutative. Commutative. What is meant by commutative? So z1 plus z2 should be same as z2 plus z1. So let us take two complex numbers. So I'll take z1 is equal to 3 plus 2i and I'll take z2 is equal to 4 plus 6i. Fine. So I've taken two complex numbers, you can see they are in a plus ib form. We add two complex numbers, z1 plus z2 you do. So it will become 3 plus 4 plus real imaginary plus imaginary 2 plus 6i. So that is 7 plus 8i. So now we got z1 plus z2. What you got? z1 plus z2. Call it as equation 1. So now I added two complex numbers. I got this. Now perform reverse. So consider. Now I'll consider z2 plus z1. z2 plus z1 reverse. Add second plus first. So second is this plus this. So 4 plus real plus imaginary 6 plus 2. Now you know what is 4 plus 3? 7 plus 8i. So equation 2. Observe 1 and 2. This is also 7 plus 8i. This is also 7 plus 8i. So therefore what is the conclusion? From equation 1 and 2 I can say z1 plus z2 value and z2 plus z1 value both are same. However you add a plus b or b plus a or first one plus second plus first, they are same. Therefore commutative. Therefore I can say addition is commutative. So what is commutative? z1 plus z2 is equal to z2 plus z1. First I proved closure. Closure means what? If I take two complex numbers and if I add, result is also complex number. ಎರಡು ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ಗಳನ್ನ ತೊಗೊಂಡು ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ಬರೋ ಆನ್ಸರು ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ ಆಗಿರಬೇಕು. ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ ಅಂದರೆ ಏನು? ನಂಬರ್ ಆಫ್ ದ ಫಾರ್ಮ್ a ಪ್ಲಸ್ ಐ ಬಿ. ಎರಡು ನಂಬರ್ಗಳು a ಪ್ಲಸ್ ಐ ಬಿ ಫಾರ್ಮಲ್ಲಿ ಇರೋದನ್ನು ತೊಗೊಂಡು ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ಫೈನಲ್ ಆನ್ಸರು a ಪ್ಲಸ್ ಐ ಬಿನೇ ಬಂತು. ಅದಕ್ಕೆ ಕ್ಲೋಷರ್ ಅಂತ ಹೇಳಿದ್ವಿ. ಎರಡನೇದು ಏನು ಮಾಡಿದ್ವಿ? ಕಾಮುಟೇಟಿವ್. ಕಾಮುಟೇಟಿವ್ ಅಂದರೆ ನೀವು ಮೊದಲನೇದನ್ನು ಎರಡನೇದಕ್ಕೆ ಆ್ಯಡ್ ಮಾಡಿದ್ರು ಅಥವಾ ಎರಡನೇದನ್ನು ಮೊದಲನೇದಕ್ಕೆ ಆ್ಯಡ್ ಮಾಡಿದ್ರು ಸೇಮ್ ಆನ್ಸರ್ ಬರುತ್ತೆ. ಅಂದರೆ z1 ಪ್ಲಸ್ z2 ಮಾಡಿದ್ರು, z2 ಪ್ಲಸ್ z1 ಮಾಡಿದ್ರು ಸೇಮ್ ಆನ್ಸರ್ ಬರುತ್ತೆ. ಆದ್ದರಿಂದ ಇದನ್ನು ಕಾಮುಟೇಟಿವ್ ಅಂತೀವಿ. ವಾಟ್ ಈಸ್ ಕಾಮುಟೇಟಿವ್ ಲಾ? ಫಸ್ಟ್ complex number plus second complex number is same as second complex number plus first complex number. z1 plus z2 is same as z2 plus z1. Now we have other property. So I have done closure, I have done commutative. Now we go for associative. So now we'll see what is associative. Associative means we'll see associative. So associative, what is associative? Associative means if you add 1 plus 2 plus 3 means z1 plus z2 plus z3 will be same as I'll group the first two, that is z1 plus z2 plus z3. Both will give you same result. So first plus second plus third or first plus second plus third, both will give you same. You can take three complex number and add them like this. LHS and RHS will get same. ನೋಡಿ, ಮೊದಲನೇದನ್ನು ಸಮ್ ಆಫ್ ಸೆಕೆಂಡ್ ಆ್ಯಂಡ್ ಥರ್ಡ್ಗೆ ಆ್ಯಡ್ ಮಾಡೋದು ಅಥವಾ ಸಮ್ ಆಫ್ ಫಸ್ಟ್ ಆ್ಯಂಡ್ ಸೆಕೆಂಡ್ನ ಥರ್ಡ್ ಒನ್ಗೆ ಆ್ಯಡ್ ಮಾಡಿದ್ರು ನಿಮ್ಗೆ ಆನ್ಸರ್ ಸೇಮ್ ಬರುತ್ತೆ. ಯು ಕ್ಯಾನ್ ಟೇಕ್ ಎನ್ ಎಕ್ಸಾಂಪಲ್ ಟು ಡೆಮಾನ್ಸ್ಟ್ರೇಟ್. ಲೆಟ್ ಮಿ ಟೇಕ್ z1. say I'll take 1 plus 2i. I'll take simple numbers I'm taking. You can take alphabets also to prove this. 2 plus 3i. I'll take z3, 4 plus 5i. Some complex numbers. Any complex number you can take. But now I'll do LHS. I'll find z1 plus z2 plus z3. Let us perform this. So that is z1 means 1 plus 2i. I need to add it to z2 plus z3. If I add these two, how to add two complex numbers? Add the real part plus I times add the imaginary part. That is 2 and 4 you add. 2 plus 4 is 6 plus add the imaginary part. 3 plus 5. 3 plus 5 is what? 8. 8i. Now you need to add this. To how to add? 1 plus 6, 7 plus 2 plus 8, 10i. So now you got LHS, that is z1 plus z2 plus z3. Call it as equation 1. Now you perform RHS and check whether you will get same. So take RHS. What is RHS? RHS right hand part is z1 plus z2. What is z1 plus z2? 1 plus 2. 1 plus 2, 3 plus, or let me write what is RHS. So first we need to prove z1 plus z2 plus z3. What is meant by z1 plus z2? So first and second complex number, 1 plus 2. 1 plus 2 is 3 plus 2 plus 3. 2 plus 3 is 5i plus z3. What is z3? Third one, that is 4 plus 5i. 4 plus 5i. So now add it. So 3 plus 4. 3 plus 4 is 7 plus 5 plus 5. 5 plus 5 is 10i. Call it as 2. Observe 1 and 2. What is equation 1? 7 plus 10i. What is equation 2? 7 plus 10i. Are they same? Yes, they are same. So therefore I can say LHS is equal to RHS. From equation 1 and 2 I got this conclusion. From equation 1 and 2 I got this conclusion. So therefore this is equal to this. Means Z1, if you add it to Z, sum of Z2 and Z3, it is same as sum of Z1 and Z2 added to this. This is associative. First we proved closure. Closure means what? Take any two complex numbers and add them. Result is a complex number. ನೀವು ಎರಡು ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ಗಳನ್ನ ತೊಗೊಂಡು ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ಬರೋ ಆನ್ಸರು ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ ಆಗಿರುತ್ತೆ. ಅದನ್ನೇ ಕ್ಲೋಷರ್ ಲಾ ಅಂತೀವಿ. ಅದಾದಮೇಲೆ ಕಾಮ್ಯುಟೇಟಿವ್. ಕಾಮ್ಯುಟೇಟಿವ್ ಅಂದ್ರೇನು? ಮೊದಲನೇ ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ನ ಎರಡನೇದಕ್ಕೆ ಆ್ಯಡ್ ಮಾಡಿದ್ರು ಅಥವಾ ಎರಡನೇದನ್ನು ಮೊದಲನೇದಕ್ಕೆ ಆ್ಯಡ್ ಮಾಡಿದ್ರು ಸೇಮ್ ಬರುತ್ತೆ. ಮೀನ್ಸ್ ವೆನ್ ಯು ಆ್ಯಡ್ ಫಸ್ಟ್ ಒನ್ ಟು ಸೆಕೆಂಡ್ ಒನ್ ಆರ್ ಸೆಕೆಂಡ್ ಒನ್ ಟು ಫಸ್ಟ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್, ಸೊ ಬೋತ್ ಆರ್ ಸೇಮ್. z1 plus z2 equal to z2 plus z1. Associative. What is associative? z1 plus z2 plus z3 is same as z1 plus z2 plus z3. Now we'll see the other property. After associative, identity, additive identity. See, additive identity means for any complex number, if you add a number, you should get the same number. So z plus identity should give you z only. So E is the identity. Solve this. So now what is E? Transfer z to that side. So z minus z. What is z minus z, my dear students? 0. 0 is the identity. Simply speaking, 0 is called as additive identity, not for multiplication. It is identity element for addition. How can I conclude this? You take any complex numbers and add 0, you'll get same. So I'll take 2 plus 3i. Now z plus 0 you do. Means 2 plus 3i plus 0 is how much? 2 plus 3i only. So therefore it gives you z only. So therefore 0 is called as what? 0 is additive identity. In addition, identity is 0. So in addition operation, identity is what? 0. What is additive identity? 0 is the identity element for operation addition in complex numbers. Or I say 0 is the additive identity. Like that we'll have multiplicative identity also. Now I have done additive identity. I hope all of you understood this. For addition, what is the identity element? 0 is the identity element for addition of complex number. So now additive inverse. Additive inverse. Inverse of a complex numbers. So now I need to find inverse of a complex number. So inverse of a complex number. So now we are done with closure law, we are done with commutative, we are done with associative, we are done with identity in addition. Now inverse. Say for any complex number, if I add its inverse z power minus 1, we read this as inverse, additive inverse, I should get identity. I should get what? Identity. So you know z plus z inverse should give you additive identity. What is additive identity? 0. So z inverse is equal to, you transfer z to that side, minus z. So for z, inverse of z is minus z. Inverse of z is minus z, and that is additive inverse. What I call it as additive inverse. For example, for z is equal to 3 plus 2y. Find the additive inverse. Find the additive inverse. Please understand, they are not asking you to find the inverse. In addition inverse, find the additive inverse. ಅಕಸ್ಮಾತ್ ಅವ್ರು additive inverse ಕೇಳಿದ್ರೆ, ಇಲ್ಲಿ ತನಕ ಕೇಳಿಲ್ಲ, additive inverse ಏನಾಗುತ್ತೆ? Additive inverse is, find the additive inverse. So they want z inverse. Z inverse is minus z, that is minus 3 plus 2y, that is minus 3 minus 2y. Means if I add this and this, I will get identity element called 0. For addition, 0 is the identity. For addition, minus z is the inverse of z. Minus z is the inverse of z. Because when you add z and minus z, you will get 0. So these are the 5 properties. My dear students, I hope all of you got all the 5 properties. Let me summarize. First is commutative law. If you add two complex numbers, you will get result also as complex number. Second is commutative law. First is closure law. What is closure law? Closure law, if you add two complex numbers, result is also complex number. ಎರಡು ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ಗಳನ್ನ ತೊಗೊಂಡು ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ಫೈನಲ್ ಆನ್ಸರು ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರೇ ಬರುತ್ತೆ. ಅದನ್ನು ಕ್ಲೋಷರ್ ಲಾ ಅಂತ ಹೇಳ್ತೇವೆ. ಎರಡನೇದು ಕಾಮುಟೇಟಿವ್ ಲಾ. ಕಾಮುಟೇಟಿವ್ ಲಾ ಅಂದರೆ, ಸೊ if you add two complex numbers, if you add z1 and z2, z1 plus z2 value is same as z2 plus z1. So z1 plus z2 value is equal to z2 plus z2. z1 plus z2 and z2 plus z1 both are same is commutative. Associative, z1 plus group z2 and z3. z1 plus z2 and z3 is same as z1 plus z2 plus z3. And identity, for addition, identity is 0. So additive identity is 0. For addition, inverse is minus z. So these are the 5 properties of addition. How to add two complex numbers? Add real part plus I times add imaginary part plus imaginary. Now similarly, subtraction also, you can subtract real and real plus I times subtract imaginary and imaginary. Addition or subtraction can be done like normal algebra. Okay, now let us discuss multiplication of two complex numbers. So let us multiply z1 is equal to a plus ib and z2 is equal to c plus id. I will multiply z1 into z2 and we'll see what is the answer. That is, I will multiply a plus ib plus into c plus id. Term wise we'll multiply. All of you know, if I multiply term wise, a with c is ac. Then I should multiply a with id, so plus ad into I. Then I'll multiply bc plus bc into I, then plus I square bd. Now I'll simplify this. That is, so I'll take non-items ac we have, and AD and BC I can take common. So AD plus BC into I will take. So now BD into I square. I square, see, remember I is root of minus 1. I square is minus 1. So it will become minus 1 into BD. Now I will group the real part. So I will get AC minus BD plus AD plus BC into I, or I into, you can write. So same thing, I wrote AC minus BD plus AD plus BC into I. This is the multiplication. So directly you can do multiplication, means real part into real part minus imaginary part into imaginary part. AC is product of real part minus product of imaginary part plus, then diagonals AD plus BC. AD plus BC into I, but here minus, here plus. There are diagonals, but here real into real minus imaginary into imaginary, this. So this is a formula direct. You can use either formula or you can use normal multiplication like algebra. I'll show. So I'll take one example for each and we'll see what happens. So let me take two complex numbers. I'll take Zn is equal to 2 plus 3i. I'll take Z2 is equal to 4 plus 5i. Any complex numbers. Two complex numbers I have taken. Let me do Z1 into Z2 according to the formula. According to the formula means AC minus BD. Real part into real part. That is 2 into 4. 8 minus BD. BD means imaginary into imaginary. That is 3 into 5. 3 into 5 is 15. AC minus BD plus you have to multiply AD plus BC. What is AD? A into D. A is 2 5s are 10 plus 3 into 5. 3 into 5 is 15i. So finally you will get 8 minus 15. 8 minus 15 is, in 15 negative you will get 7 plus 25i. I am using the formula called AC minus BD. Real part into real part minus imaginary into imaginary plus I into real into imaginary. AD plus BC. This is the formula I used. Now I'll do the same problem term wise. So finally we got the answer 8 minus 15. So in 15 if you remove 8 that is minus 7 plus this. Now I'll do term wise, like normal algebra multiplication if you do also I'll get it. That's what I want to say. Means there is no necessity to multiply or memorize the formula what I have written, but that formula holds good. If you memorize, your speed will be more. If not, normal multiplication you can do, no problem. So but you should know I square is minus 1. What is I? Root minus 1. What is I square? Minus 1. This you should know. Z1 into Z2. That is, what is Z1? 2 plus 3i into 4 plus 5i. Now we'll multiply, we'll do multiplication term wise. So now my dear students, 2 into 4 plus 2 into 5i. I am multiplying term wise. Then 3i into 4 plus 3i into 5i square, 5i. That is 2 4s are 8 plus 10 plus 10i, sorry, plus 3 4s are 12i plus 3 5s are 15. I into I is I square. So 8 plus 10 plus 12 is 22i, and then this is 12 plus plus 15 into I square is minus 1. Further 8 plus 22i minus 15. Now numbers 8 minus 15. 8 minus 15 if you do minus 7 plus 22i. So you got same answer, you can see. See here, what is it? What is the formula? AD plus BC. What is AD? A is what? 2 into 5 plus BD. BD is BC, sorry, 3 into 4, 12. Sorry, this is 12, right? So 3 into 4 you should multiply 12, so it will become 22. Sorry. Imaginary into imaginary you should do. So then you will get this. So here 8 minus 5, then here multiply real with imaginary, imaginary with real. So this is AD. A means what? Real. D means what? Imaginary. Plus imaginary multiply with what? Real. Opposite. When you do 10 plus 12, 10 plus 12 is 22. So here also you will get minus 7 plus 22i if you use formula, and if you do directly also you will get same. If you don't remember the formula, you do directly, it is same. If you remember the formula, it is faster. And my guidance, if you are using the formula, write one under the other, the process becomes faster. For example, Z1 is 5 plus 4i. Z2 is 2 plus 3i. So now Z1 into Z2. Z1 into Z2 means real into real. 5 2s are 10 minus imaginary into imaginary. 4 3s are 12 plus crisscross. 5 3s are 15 plus in the formula 2 4s are 8 I. That is 10 minus 12 is minus 2 plus 23i. When I use the formula AC minus, what is the formula? Real into real minus imaginary into imaginary, and plus real into imaginary plus imaginary into real. When I use that, I will get it. So now similarly we can also use other formats. So now going ahead, closure law. So in addition I taught you sum of two complex numbers is complex numbers. Similarly product of two complex numbers is also complex number. That is closure law. Commutative means Z1 into Z2 is same as Z2 into Z1. Means however you multiply, both the results are same. Associative, Z1 into group of Z2, Z3 is same as Z1 into Z2 into Z3, like addition. So now identity. So in addition I told you identity is 0, but in multiplication, so for you they'll ask inverse and identity for multiplication. So identity for multiplication is 1. What is the identity element for multiplication? 1 is the identity element for multiplication. 1 is the identity element. 1 is the identity element for multiplication. And multiplicative inverse. So Z inverse is 1 by Z. Multiplicative inverse is what? 1 by Z. Multiplicative inverse of Z is 1 by Z. Then, so this is 1 by Z. Now for any complex numbers, 1 by Z is the multiplicative inverse. For that we can also use conjugate rule to find. Then finally distributive law. So outside product, inside sum. Z1 into Z2 plus Z3 is same as Z1 Z2 plus Z1 Z3. Take it inside. So distributive law. But you should remember what is multiplicative inverse. For a complex numbers, its reciprocal is multiplicative inverse. If I use Z, Z inverse is 1 by Z. So in my next coming session, I'll add up with the problems and I'll make you thorough with some simple techniques also. So these are the properties which you have to be thorough with. Multiplicative inverse is 1 by Z, and distributive law Z1 into Z2 plus Z3 is Z1 Z2 plus Z1 Z3. So the properties become thorough, and then we'll see problems. So I told you, if I give Z inverse is what? 1 by Z. If I give Z is equal to 3 plus 2i, and Z inverse is 1 by 3 plus 2i. But if you write like this, they'll not give marks. So any problem should be in A plus IB form. Further we'll convert it into A plus IB form. Now time being, you should know what is Z inverse. Multiplicative inverse is reciprocal. What is multiplicative inverse? Very, very important. Multiplicative inverse of Z is reciprocal. 1 by Z. Why? Because Z into Z inverse should give you identity, and identity element is 1. So only Z into 1 by Z can give you 1. So therefore, what is a Z inverse? So Z inverse value, inverse of Z is 1 by Z. 1 by Z will not be in standard form. To reduce it into standard form, A plus IB form, we have to rationalize. That we'll see. My dear students, in today's session, I started with what? Complex numbers and quadratic equations. I taught you what is a complex number, and I taught properties of addition and properties of multiplication. I'll see you in my next session with problems based on complex numbers. We'll be discussing what? Problems based on complex numbers. In today's session, iota. I is equal to root of minus 1, I square is minus 1, you should know. Any number of the form Z is equal to A plus IB, where AB belongs to real numbers and I is imaginary, you should know. Thanks for attending the session. I'll see you in my next session. Thank you.